In section 2.2, we begin our preparations for proofs. This section introduces you to logical statements, and logic is going to be a key component to figuring out the proofs we will start later on in this chapter. So let's start with these conditional statements. These if-then statements go by a lot of different names. You certainly can call them if-then statements. Sometimes an if-then statement is simply called a statement, also sometimes referred to as a conditional statement, and then sometimes this is shortened to simply a conditional. But whether you call it an if-then statement, conditional statement, or conditional, they all refer to the same thing. And usually it is best to see an example of that thing, so let's do it now. Here's our first if-then statement. You can probably see where it gets its name from. If-then statements are logical statements. You're going to have to put your life experience and common sense to use while dealing with them. Here we say that if today is Tuesday, then tomorrow is Wednesday. That makes sense. It may not be Tuesday when you are watching this, but if you put yourself in that situation, you think, well, if today was Tuesday, then yes, tomorrow would be Wednesday. Here we have another conditional. Even if you don't actually live in California, when you read the sentence, you put yourself into that situation and see if the next part makes sense. This conditional makes it seem like Manuel is a creature of habit, and absolutely every time it rains, he is donning a raincoat. And finally, we have this nonsensical one. This is here to show you that we currently don't really care about the true or false nature of a statement. Heck, we're not even caring whether it makes sense or not. At this point, this conditional is here to show you that for now, we only care about the structure of the sentence. And this sentence is structured like an if-then statement. For all the conditional statements on this page, you can break them down into two pieces. The hypothesis is what comes after the if. So for the first statement, the hypothesis is, today is Tuesday. For the second statement, we have a hypothesis of, I live in California. For the third statement, it is raining today. And finally, for the last statement, we have, the ants are protesting the war today in the park. The second half of the if-then statement is the conclusion. It is everything after the then. On the first conditional, the conclusion is tomorrow is Wednesday. On the next conditional, the conclusion is, I live in the United States. Next up, we are concluding that Manuel will wear a raincoat. And lastly, the conditional statement concludes, the birds will do the Macarena while dressed as clowns. Which really, I wish I had time to animate, because I think that would be pretty funny. So we can generalize our if-then statements to be, if hypothesis, then conclusion. We want to be able to memorize that and to talk about it, but clearly that is way too much writing, so there is shorthand for it. Here it is. I don't know why the letters P and Q were chosen for this, but I didn't make them up. They are the standard letters to use. Some students really wish they were H and C instead, but we don't get to choose, so P and Q it is. Hopefully it is obvious, but P stands for the hypothesis, and Q stands for the conclusion. For many people, that was lovely shorthand for this, but somewhere along the way, someone decided that wasn't shorthand enough. Still way too much writing. They could do better, so they came up with this, which says the same thing. It's super shorthand. Hard to get any smaller than that, but I'm sure someone out there is trying to adopt an even more minimalist approach. In any case, you can use whichever of these you like. Whatever works best for you is fine. Now we come to the converse. For the converse, you take the original statement and switch the hypothesis and the conclusion around. What was once the hypothesis is now the conclusion, and what was once the conclusion is now the hypothesis. Of course, once the switch has been made, I should really relabel these things. The conclusion is now the hypothesis, so I should name it hypothesis on this page, but I will keep it like this so you can see what is going on and the switch that has been made. Like the other statement, you can use shorthand for this if you like. Or, if you prefer the super shorthand, you can do it like this. Let's see an example. Here I have a statement we went over earlier. If I want to write the converse, the conclusion tomorrow is Wednesday becomes the new hypothesis, and the hypothesis today is Wednesday becomes my new conclusion. Here's what it looks like. All we did was take this and move it here, and all we did is take this and move it over here. That's all there is to the converse. You just switch the places around. Now we have the inverse. And with the inverse we introduce negation. For the inverse we don't switch anything around, but we negate each one like this. Now we want the opposite of the hypothesis and the opposite of the conclusion. In a sec I will show you what that looks like. For now let's just focus on the structure. We do need to remember this, so you can write it like this, or if you prefer shorthand, or if you prefer the super shorthand way. Here you have this symbol standing in for not. So many of my students call it the squiggle, or the little wave thing. So few actually know the name of it. It is actually called a tilde. That's not vocab you need to know, but just your bonus fact of the day. You have seen it countless times waving at you from the top left corner of your keyboard. Now you know its name, say hi. Name aside, the tilde is standing in for the not, since clearly that was too much writing. So here we have our original conditional again. If we apply the structure of the inverse absolutely literally, then we end up with this. If not today is Tuesday, then not tomorrow is Wednesday. Ugh. By all means, clean up the English to make it readable and meaningful. If it originally was today is Wednesday, then what is the opposite of that? Where should we put the not instead of at the front? If today isn't Tuesday, then tomorrow isn't Wednesday. That is much better. You should definitely clean up the English before you write your inverse down. And the last type of conditional in this section is the contrapositive. The contrapositive is the converse of the inverse, or it is the inverse of the converse. Either one. Doesn't that sound great? It actually isn't as bad as it sounds. It looks like this. You switch the hypothesis and conclusion, just like we did with the converse, and then we negate it just like we did with the inverse. See, that isn't so bad. Of course, there is shorthand. And if that doesn't do it for you, there's super shorthand. Look, the tildes are back. So here is our trusty statement again. To do the contrapositive, we want to flip it around and negate it like this. That is the literal translation. Once again, clean up the English, and this is so much better and makes so much more sense. Definitely do that on your work. Here is the summary of it all. You can use whichever one you like. You certainly don't want to do all of these. You just need to pick the one that speaks to you to help you keep them straight so that you know how to do each of them. Now we will actually delve into the true or false nature of these conditionals. When you are trying to determine whether something is true or false, you have to assume that the hypothesis is true. So when I said, if today is Tuesday, then you assume it is true and you push yourself in the situation that it actually is Tuesday. With that assumption, you then have to determine if the conclusion actually works based on that hypothesis. For this statement, we assume today is Sunday. Even if it isn't Sunday when you're watching this, you assume today is Sunday. And if that is true, then this whole statement is definitely true. If today is Sunday, then it does have to be the weekend. It is important to note that a statement is only true if it is true for every case of the hypothesis. There will be many times where the hypothesis has a bunch of different possibilities. In this example, there are 52 or 53 Sundays every single year. For every one of those Sundays, it is the weekend. So this statement works for every single case. That's what makes this conditional true. For every single one of those Sundays, it is the weekend. But if the hypothesis fails to produce the conclusion even a single solitary time, then the statement as a whole is false. You need to get this vocabulary down, but when you can show one situation that breaks a conditional, that makes it false, that is known as a counterexample. Often there will be more than one counterexample, but you only need to show one of them to say a conditional is false. So we have this true statement. What about its converse? First, let's write the converse down. Now we will assume that it is the weekend. If it is the weekend, does it have to be Sunday? No, it could be Saturday. So if it is the weekend, half the time it is Sunday, half the time it isn't. Even though it is sometimes true, you can only label a conditional as true if the conclusion is always true. So we would put down false for this one. Generally, when giving false as an answer, you will often write down one counterexample to show why it is false. When you give your counterexample, you give something which is true for the hypothesis. So, for my example, I said today could be Saturday, and that is true for the hypothesis, but that is not true for the conclusion. And Saturday isn't Sunday the last time I checked. Again, you only need to give one counterexample. This conditional and converse also show that sometimes one will be true and the other will be false. That's perfectly okay. Here's one more example. Here I have, if today is Thursday, then it is Thanksgiving. So put yourself in that situation. Assume that it is Thursday. Does it also have to be Thanksgiving? No. There are tons of Thursdays that aren't Thanksgiving. In fact, most of them aren't Thanksgiving. For your counterexample, you don't need to list all of them. Just list one Thursday that isn't Thanksgiving. Now if we look at the converse, we have this. Here we assume that it is Thanksgiving. If it is Thanksgiving, then it's sad you're working on math. Go eat! But wait, if we do assume it's Thanksgiving, then that does always fall on a Thursday. It works for every single Thanksgiving, so we can say that this conditional is true. Note, this also illustrates that sometimes your statement is false, but your converse is true. Now let's work through some examples and see if you don't notice a pattern. Here I have a statement from before, but I've also written down its converse, inverse, and contrapositive. You can take a moment here to figure out the true and false nature of them if you want. For the first statement, that is true. For the converse, there are lots of possibilities for where I could live in the US which are not California. I only need to list one of them as a counterexample. There are 49 states you could choose from. It would be torture to make you list out all 49, so you only need to list one. For the inverse, we have the same kind of thing. I only need to list one, and I might as well use the same state. And finally, we have the contrapositive. And you could live in a lot of different countries other than the US, but no matter which other country you choose, you would also not be living in California. So this one is true. Here we have a new statement, and the first one that looks mathy. Yes, that's the technical term. You'll notice that there is still the familiar if-then structure for them. You should also take a moment to look at the inverse and contrapositive, which include negation. The inverse would be the opposite of x equals 4. And the opposite of that is not equals 2. So that's what you should write. This is what the not equal sign symbols are for. Let's take a look at the true-false nature of them now. Pause if you want to think about them first. If you quickly plug in 4 for the x, you'll see the conclusion works. So that's true. If you flip it around, then x must be 4. There is no other option. So that's also true. It's a little harder for most people to think about when the equation has a not equal sign in there, but this one also works. And finally, flipping around doesn't change anything. They all work. This one is a little harder for most people to wrap their heads around, especially the last two. So here we have a statement about the end of February and the beginning of March, which has that pesky leap day sometimes there and sometimes not. If tomorrow is March 1st, there are two possibilities. Since the hypothesis doesn't always work, we have to label it false and give a counterexample for why. The converse is a bit easier. If we assume today is February 29th, then it must be a leap year, and we know tomorrow must be March 1st. Here's where it gets tricky. You can think about these next two if you want, but I'll use the fact that they are hard to parse as a reason for the next 2 pages. Without much explanation, the inverse is true, and the contrapositive is false. Remember, I'll explain in a second why I can breeze through these two. Here's a summary of what we just went over. Do you notice a pattern? The items come in pairs. These pairs are always the same. They are always either both true or both false. The statement and contrapositive are always the same. The converse and inverse are always the same. Always. You can use this fact to help you out at times. In that last example with leap year, students usually find the statement and converse are much easier to figure out than the inverse and contrapositive. However, if you know that the statement and contrapositive are always the same, then you only need to figure out one of them and you can automatically put in the other one. That's why I breezed through those last two on the previous slide. We didn't need to bother with them too much. Once we knew the statement, we also knew the contrapositive. Once we knew the converse, we also knew the inverse. You will find that this is extraordinarily helpful. It is often the case that either the statement or the contrapositive is much easier to figure out than the other one. So figure out the one that makes the most sense and is the easiest to figure out, and then you automatically know the other one. It works the same with converse and inverse. So keep that in mind. These come in pairs. The only trick is remembering which one is which. Students can often remember they are paired up. They just can't remember how they pair up, which is kind of a big deal. Generally speaking, students find it helpful to remember that the two verses are a pair, the converse and inverse. And if the two verses are a pair, then by the process of elimination, you should know that the other two are a pair also. Hopefully that helps you keep them straight.